it's my pleasure to introduce Eric Singer, who I've known for several minutes now. So I just met him a few minutes ago, but I've actually known of him for a long time. I used to teach the undergraduate manipulation class, and I would start every class by showing videos of whatever cool thing I could find. And some students sent me a video of a thing called Guitar Pop. And I thought it was pretty interesting. Not only, I love robots and I love music, so how can you go wrong? But this is actually a little bit beyond that. It seemed like it sort of was a reinterpretation of the guitar idea, or a new implementation of the idea of how you organize a guitar, which seemed so startling to me. And then I was very, very pleased to hear later that actually this fellow who had developed that was one of our alums, an ECE bachelor's student from, when was that?
A long time ago.
So I'm certainly thrilled to have him here and looking forward to it. And so please welcome back to Carnegie Mellon, Eric Singer.
Thank you. I think it's amusing that you have a course that you called Undergraduate Manipulation. There was a lot of that back in my day, too.
That's the unofficial title, I forgot.
Hi, you know who I am now, so I don't have to repeat that. And I'll tell you that I started my path in making strange musical instruments when I was a student here. Fortuitously, you probably know as an engineering or robotics or computer science student that you very rarely get to take anything outside of your school or major. But I was lucky enough to kind of have a few courses where I could twist things into computer music projects, and also lucky enough to take some electives with Roger Dannenberg, who I saw walk in here. There he is. And those were my first computer music classes. And so I came from a background of music, playing saxophone, playing in jazz bands and things like that. And that was, I don't know, someone tell me, is that left brain or right brain? That's one side of the brain. The famous Eric Paulus. I'll tell you at the end why I know Eric. And then I had my other side of the brain that did engineering, and I knew they talked to each other every so often, but I didn't know that they could actually join forces and be a career or a path in life. So I did a few projects here for, as I said, for engineering classes. One was hooking up some controls to an analog synthesizer, and analog synths were like, you could just go out and buy them. Back then, you didn't have to go onto eBay and search out, the really classic Moogs and things like that. So I had a synthesizer and opened the thing up, and it came with a schematic and just like what you'd call circuit bending today. Just got in there and hacked into it and used an Apple II computer to control it. So I am dating myself now. It's Apple II Plus, and not even a 2E. So I did that, and then I got into Roger's classes, and after those I said, hey, I want to do an independent study. I want to build a MIDI saxophone. And here's the last remaining proof that I actually did that. It's a bad Polaroid of a bad photo of a bad scan on a bad background. But what you can see there, and on the screen it's kind of actual size. So it was a board about that, actual size would probably be about as tall as me. All right, it's 2 scale. So it's a block of wood with slots cut in it and switches on it set up like a saxophone, and a breath controller or wind controller that someone gave me, I think someone from Robotics. It was about this big, and it was state of the art at the time, of course, and now breath controllers can be this big, or wind or pressure sensors. And the mouthpiece, besides feeding the breath sensor, I put a little LED and a photocell in there to sense lip pressure, so really like a saxophone. And since we didn't have things like Arduinos or basic stamps or any real 8-bit micros that you could just burn from your PC, I built a plug-in card for the Apple II, probably wire wrapped together. If I don't know, people still do that, and plugged it into the Apple, programmed it naturally in 6502 assembly. I'm sure you're all familiar with that, and got it to work. And got play the sax, have it run out MIDI from the Apple, and play a synthesizer. And I was really excited about that. And then Yamaha came out with their WX7 like the week after or something like that. Real nice factory produced mini sax. But as an exercise, it was invaluable and really turned me on to building new kinds of instruments. And so then I graduated, and I stuck around Pittsburgh for a year trying to see if my rock band would get signed, as everyone who's playing in a rock band probably does. And 99.99999% of the time, of course, that fails. And so I went from Pittsburgh to Boston, to Berklee College of Music, to pursue a saxophone degree, because I thought, all right, well, I worked on one side of the brain. Someone has to look this up for me, which is the technical, which is the creative side. So someone look it up on your iPhone. Which, sorry? Okay, is there a way to remember that? Okay. Technical side, creative side. So anyway, went to work on saxophone there, and then very quickly sniffed out the music synthesis department and kind of never looked back. So I switched over to music synthesis there, and I met a guy named Richard Boulanger, who is a brilliant guy, professor and a composer, and a guy who's into software synthesis and a program called C-Sound, a program called Max, which I'll talk about in a minute, and alternative music controllers, different kinds of musical instruments that aren't just keyboards. And so he kind of showed me the way and said, you should get into this stuff. And then for a couple of years after I graduated, I was his assistant and programmer, and I went all over the world with him, performing on things like radio batons, which is a conducting surface, and Mattel Power Gloves, the Nintendo Power Gloves. Some of you might remember those. Basically, it was around when data gloves were hot. And the thing about the Power Glove is that as a video game controller for controlling Mario to jump the turtles or whatever you do, it was terrible. It was completely useless as a game controller. But as a music controller, it was awesome, because you had X, Y, Z and rotation and a bunch of bend sensors and a bunch of buttons on the back. So you had all these axes of control. Hook it up into the computer through an interface that one guy made at an engineer at Digital Equipment Corporation. So this strange interface that you could get which was one side in was Nintendo and the other side out connected to the old Apple keyboard bus. But you could get Nintendo data into it and use the glove as a controller. And we'd run that into a program called Max. Because most people outside of computer music and live video and things like that don't know about Max, I'm going to show it to you right now because I think everyone in technology that's interested in art and interactivity, anything like that, should know about this program. And even if you're just sitting around programming, prototyping graphics or things like that, it's also an invaluable tool. So just for the hell of it, and since this worked at a lecture I did a couple days ago, I'm going to write a Max program right here in front of you that's going to do something slightly banal but semi-useless or useful, semi-useful. By definition, if something's semi-useful, it's also semi-useless. So Max is what you would call a graphical programming environment and graphical programming language. And why am I going into this stuff? Because almost all of my work, all of the programming behind my work is based on Max. If it's not on a microprocessor, then I'm doing the control through Max. So the way it works is basically a synthesizer patching paradigm. So it's very easy and quick to throw together a program. So if I want to make a thing that generates some notes at a particular tempo, I can put a metronome object there and tell it to beat time at every 100 milliseconds, that's time in units in max. I'll put a checkbox there so I can turn it on and off. I'll put a number box so I can control that, the tempo of that metronome, and have it generate 2 octaves worth of random numbers, transpose it up. This is a little, musical stuff, but you'll get the idea. Let's put another number box down here so you guys can see what's coming out, and turn it into a MIDI note that's loud and short, and send it out to the internal synthesizer, which is what comes up there by default. Save it as fun, and so, like I said, semi-useless, but by extension of what I just did, if you can understand that Max can process MIDI, and I'll tell you what MIDI is in case you don't know in a second, processes MIDI data, processes digital audio through patch cords as well, and processes digital video. And you can talk over serial lines, and you can talk over Ethernet via USB and things like that. And so you basically have this program that can connect everything, and it works on the fly, it's interpreted, and it is just a really simple way to kind of just generate interactivity. You can take in stuff from controllers, use that to control live video. You could bring in sound and analyze it, and have those, the sound parameters control robots, whatever you want to do. I'm sorry, I realize I glossed over MIDI really quickly. MIDI stands for Musical Instrument Digital Interface, standard for connecting synthesizers, computers, and other types of musical instruments, electronic instruments, together. It's been around now for 30 years, and it's still really good and relevant, even though it's too slow and doesn't have enough resolution, all this kind of stuff. It's what we use for all of the robots. The reason we use MIDI, or the reason I said I'd like to put a MIDI port on everything I build, is because then you can control it from any MIDI software. And any software that does music, virtually any software that does music, and a lot of programs that do other things related to electronic art, they all talk MIDI. So it's a standard, and when we have composers come in and work with the robots, if they know MIDI, and almost everyone does, and they know whatever, any program they want to use that sends MIDI, just works automatically. So that led to, given the fact that after leaving Carnegie Mellon, it was now difficult to do hardware, because this is in the early 90s, and didn't have access to the resources here, and there weren't these little microcontrollers, and so all of a sudden I was kind of frustrated, like, all right, can't really do electronics projects that easily, can't build stuff, didn't have a machine shop or access to anything like that. And so I moved into software for a long time. And the stuff that I did with Dr. Boulanger was software and programming and a lot of stuff in Max, things like that. And so, I did that for the entire time I was in Boston. And then he pushed me to go to grad school, and I ended up at NYU in computer science. I would have gone engineering, but NYU didn't have an engineering school at that time. They recently bought themselves an engineering school, Metro Tech or Brooklyn Polytech in Brooklyn. But back then it was computer science. And, it's a traditional computer science program, but I, again, found ways of using electives and things like that to do computer music stuff. I also got affiliated with a lab there called the Media Research Lab, which, for lack of a better description, is kind of like NYU's Media Lab. And worked with a guy named Ken Perlin there, who's fairly well known in the graphics world, and did a lot of stuff with programming for interactive video and animated characters and things that kind of eventually found their way into games. And now everyone is used to, but back then it was kind of cutting edge, like characters that would just control themselves and move around based on their personalities. So we made a saxophone player that could listen to a keyboard, and then he would play a solo along, so we did some algorithmic composition or improvisation. And we would also control his movements. So, I'm sorry. It's bedtime, isn't it? And I'm boring. Oh, so I'll just talk straight for an hour and leave everyone in the dust if you're confused about anything. So feel free to interrupt me at any time and go, what? And I'll stop and explain something. So anyway, so again, more software, combining music and graphics and that kind of stuff. And then, all of a sudden, little 8-bit home programmable microprocessors started hitting the market. And that was pretty revolutionary, especially for people who were into doing electronics at home, which was me. And they were really easy to program at the time, we thought. They were actually really hard compared to what you do now, but you get a special programmer and you get a chip that's got a little window on it, and you tape over the window, and you put it in, and you write your program, compile it, and put it on there. It takes about a minute to burn it, and then you run it, and you realize there's a bug, so you print some stuff out the serial port, and you go, okay, I think I know what's wrong. And then you take it and put it in a UV eraser. Sits in there for about 15 minutes to get rid of the program that's on there. And you grab another chip off the shelf, you stick it in the programmer, and you try again. So you're just, basically you have half a dozen chips, and you're just kind of rotating through into the toaster, back onto the shelf, and this was how you would write a program for it. But you could. And until that time, you really couldn't unless you bought into someone's fairly expensive development kit and a big board like this and that sort of stuff. So now all of a sudden, these little microprocessors that you could just do any kind of electronic input and output were all of a sudden available to us. So some of the early stuff that I did with them was get back to making musical instruments. And I'd been trained by that time to think of anything as a potential musical instrument. And like I said, it was still around the time when data gloves were popular. And so I made my own version of a data glove. It was wireless. It had bend sensors on the fingers, pressure sensors on the fingertips. And in this video, I'm just using them as triggers, but you can get continuous data off of them. And this is dedicated to all of you Bugs Bunny fans when you hear the samples. So I'm just playing back samples by triggering, and then every time I bend, I'll get a new sample on that finger. And as we advance through here, you'll sort of notice a bit of a comic theme to my work. So. You get the idea. I actually did a live performance using this with a DJ once. I think it was just really confusing for people. And it was also, like someone said to me after, like, I understand what you're doing, but the audience has no idea that someone could be wearing a glove and making cartoon sounds come out of a speaker. It's like not in anyone's purview at this point in time. So you might want to explain that next time. It's also certainly not in people's purview that you could take a rubber tube and turn it into a musical instrument. And the idea behind this instrument, which is called the Sonic Banana, because I painted it yellow, is it's got 4 bend sensors in it that run along the tube. So there's kind of 4 locations you can bend, and a button on the top. So that's all you get. If you plugged it into a synthesizer, it wouldn't do anything. You plug it into Macs, and you can make it do anything that you want. The musical instrument is in one half the physical interface and the other half the software. When you think about this, it's kind of revolutionary in the history of musical instrument design. Because before electronics, of course, the sound coming out of an instrument is intimately tied to the physics of the instrument. So you can't, unless you're really, really good, you can't get a saxophone to sound like a violin. In fact, I've never heard someone do that yet. If you guys know someone, send me an MP3. But so it was always, if you play a violin, it's going to sound like a violin because that's what the physics dictates. But now you can make a violin controller and have it sound like a saxophone, or have it sound like an alien spaceship, or whatever you want. So that's the thing about controllers. You've just now decoupled the gesture from the sound that comes out of them. So the possibilities are kind of endless at this point. And so this program is what you call an arpeggiator. It goes up and down scales, and I can change the pitch and the scale and the speed and all this kind of stuff based on where I'm bending. I'll just add one other thing, is if you're going to play a very silly musical instrument like a rubber tube, you have to adopt a very serious expression so people take you seriously. So. You think I was Itzhak Perlman or something like that. I'm going to go forward here now. So at this point, I'm kind of playing around knowing what all the sensors are doing, but I think this stuff gets more interesting when you forget about it, or you hand the instrument to someone else, and they just start bending it and seeing what they do, kind of exploring the space of possibilities. So here I'm just bending the hell out of it, seeing what it does when it gets into certain kind of pretzel shapes. Grand finale, so. And if I were to hand it to Eric's son, he would immediately try to tie it into a pretzel, put a knot in it, and I've seen this from kids, not from Eric's kid. I'm sure he's actually not that destructive, but so just very briefly, you know, change the software, you change the instrument. So this one has got a little bit, sort of an accordion algorithm. And there's a little kind of wind simulation there. Like pumping it up and you let go and it sort of dies out. So I'm only going to show you little excerpts of this stuff, or we'll be here till midnight. But all of this video is on my websites, and they're hiding behind the screen, so I'll show them at the end. Okay, goodbye, saxophone. So this is what I did for many years. Build controllers and write software for them and play around with them. And then I took a little detour and went to Burning Man. For those of you who don't know what Burning Man is, it's a festival out in the Nevada desert. Does anyone not know what Burning Man is? Okay, then I won't bother explaining it. All right, you all know what it is. I went there in '97, and it changed my life, which is, you know, it does to a lot of people. Mostly what it did was change my idea of what art could be. And that art could be gigantic and, you know, intricate. What's the word I'm looking? Intricate, yeah, right. Intricate and could be lit on fire and all of these sorts of things. So I came back from there. I went with a few people. We came back from there, and we were really excited, and we started an art group called the Madagascar Institute. What does it have to do with Madagascar? Absolutely nothing. My partners picked the name. I wasn't there for that discussion. So anyway, the Madagascar Institute, which continues to this day, is a collective of machine artist, pyro geek, guerrilla street theater performing, carnival ride making misfits of various kinds. I make that up every time I say it. So, and so, you know, what we did was start learning how to weld and start, you know, learning how to make things explode and start doing street events where street events weren't supposed to happen, and there'd be a parade in the middle of the village, and the cops would be standing there going, why is there a parade going by that we don't know about? And because I talked about this in my last lecture, but didn't show anything and just, again, left people confused. So we're doing stuff like this. Get a couple hundred people together, tell them to dress up in costumes, and have them parade down the street. Get your friends that play in a marching band together. Cops try to figure out what's going on, but they can't, because frankly it doesn't make any sense. And then you parade through the street, and like every good Italian parade and every good Madagascar Institute event, it ends with a whole lot of fireworks going off. And there was much rejoicing. I'm going to bring it back to this in the end so you'll know why I took this detour. So, I came back, we did that, and we opened a shop. One of the guys in the group bought a building, we put a shop in there, and now we could build things. And so after a few years there, I started thinking, well, let me get back to my engineering work and come up with a new project for that. So I started thinking, well, I've been doing controllers that humans play into a computer, and that makes sound. So what about reversing the direction? Instead of a MIDI input device, create a MIDI output device. And, well, traditionally that would be a synthesizer, but I wanted to take it to a level that I thought was interesting. So I thought, all right, well, let's make them play mechanical parts and make robotic musical instruments. And so I talked to a bunch of my friends and colleagues, and half of them said, "Hey, that's really great. Yeah, I'm in. I'll help you do it." And half of them said, "What?" So I took the half that didn't say what, and we formed this group called Lemur. As you may know, lemurs are indigenous to Madagascar, so I figured if I'm going to do a project as a spin-off, it should be called Lemur. And fortuitously, I was able to figure out that Lemur could stand for League of Electronic Musical Urban Robots. So the acronym came first in this case. So we started prototyping things, building things in the shop, and I recruited a couple of robotics engineers who worked for a company called Honeybee Robotics in New York. And I did that because we had everything in the group, including people who knew electronics, programming, sculpture, musical instrument design, all of these things, but no one who had any robotic or mechanical experience. So I got a couple of guys in the group, then we got some grant money, and we were all ready to build some machines, and the robotics guys quit. So we're like, oh, okay, so I guess we got to figure this out on our own. So I went to a friend of mine and took some machining lessons, learned how to use a mill. And then we bought a mill, and we all started playing around with it. And it's like, it's kind of like a glorified drill press. It's very glorified, and it does a lot of really good things, like cut metal up, down, and sideways. And then we just started experimenting. And I sort of said, put the mission out to the group, like, all right, just, if you got an idea, get a few people from the group and just start working on it. So we had a lot of people working on different projects. And so I and a couple other people started working on a robotic guitar. Why a robotic guitar? Well, being a saxophonist and coming from that background, I have no idea, except for the fact that one day as a teenager I woke up obsessed with the idea of making a guitar that could play itself. Maybe it was because the first instrument I ever built when I was like 6 was a shoebox guitar where you string the rubber band on and you bum, 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 bum. So, I was always kind of thinking about guitar because I loved the sound of it. I liked the music that was played by it. And eventually I learned how to play the guitar by playing along to Ramones records, so I'm that good. I can play anything on a Ramones album that doesn't have actually individual notes. It's got to be bar chords. And I guess I kind of thought, well, maybe it'd be good to make a guitarist that was better than me. So also one of the things I thought in the beginning is, humans are really good at playing instruments designed for humans. And I wasn't really into the idea of just taking robotics and putting it onto existing instruments. And we did that later on, and you'll see some of that. But at the time, I thought, well, let's make instruments that robots are good at playing. And why not also, if we're building new instruments, let's build new instruments, build them from the ground up. I was also very consciously trying to avoid the Chuck E. Cheese teddy bears playing the banjo aesthetic. So I didn't want anything that looked like, C-3PO playing a guitar. So we created the Guitar Bot, and here it is finally. It is a, let's see, are we running? Never start your videos out in black. There we go. While it's rolling the credits, I'll explain what you're about to see, and that is a 4-stringed slide robotic guitar-like instrument, because it's clearly not a guitar. And each of these strings is independent, so they can do whatever you want. So it's kind of like having 4 single-string slide guitar players at your beck and call. This was the first piece created for the instrument, too. So what's going on? I want to stop it here, and then I'll let it play a little further till it gets to the really kind of bitchin' part. We've got slides going up and down. What you may not be able to see is that there are strings on each of these plates, and you move. Okay, and there's this piece here is the bridge. It moves up and down, and that's what controls the pitch. What you saw earlier on, was a nice close-up of the pick mechanism. And the way that works is there's 4 guitar picks on them, Fender mediums, like every guitarist uses. And each time it has to play a note, it turns a quarter string, or a quarter turn, and it plucks the string. And then right over here is a damper. It's a solenoid damper, and it just comes down on the string to stop it. So what does this mean for a musician or composer that's using the instrument? Well, it means that all they have to do, because each of these has a microprocessor on the back that has all the smarts and a MIDI port, all they have to do is write notes for it, and if they say play a middle C, the micro figures out how to move the parts around to pluck a middle C. And if they say, all right, stop playing a middle C, the damper goes down, stops the string. So from a composer's standpoint, it's just like writing for a synthesizer. And you can do any of this stuff in real time. Although this piece was composed first, pre-composed, it's being played back live and recorded live. So this is all happening in real time. No overdubs, a little bit of post-processing to the audio, which you'll hear in a sec. So there's this pick wheel on the bottom. In case you're wondering, there's a little wheel here that's pie wedges. There's like black, clear, and photocell that's sensing it. So the way the micro knows how to turn the guitar pick is it starts the motor and the pick is in position to pluck. So turns it, it goes pluck, and then when that wedge interrupts the light, sends a signal to the micro, which then stops it in position for the next pluck. So it's always going turn, stop. And the solenoid, obviously, it just sends a signal to it to put it down on the string long enough to stop. The interesting part is, of course, the slider mechanism. And the way that works is you can kind of see this. There's a motor sticking off the back. It's driving a pulley, and that's driving a belt, which is driving the slider up and down what actually turns out to be a drawer slide, like the thing that lets you do that without the squeak. It's a drawer slide that we've cut off like 80% of, and this was one of the hard parts because I had no idea like how do you create a slide mechanism. So you can kind of figure out that this is obviously like the head of an inkjet printer, basically. And one day I was like looking around the office, and I saw a drawer slide sitting on the table, and I was like, aha, it's a drawer slide. That's what I need. So I got drawer slides for that, and put the bridge on there, and connected the belt to it, and we have the motor driving it up and down. And then on the bottom, on the other pulley, which you can see now, that goes to the back to a potentiometer, multi-turn pot, which is just works as a positional sensor. So now the microprocessor knows where the slider is, and if you give it a high pitch and a low pitch reference, or rather low pitch and a high pitch, because these are lower notes, you tell them, this is the lowest note and this is the highest note 2 octaves up, because it's a 2-octave range. Then it just computes the positions of all of the other virtual frets on there. So now it knows C, C sharp, D, D sharp, etc., all the way up the string, and that's how it can take a MIDI note and slide to where it needs to go and play. So the fun part is when the distortion kicks in. Like I said, all of this is on the website, so I'll just play little bits of it. All right, so that piece was composed by a guy named Joshua Freed, avant-garde composer from downtown New York, but with a pop sensibility. Or maybe he's a pop composer with an avant-garde sensibility. Anyway, he's a good guy and a good composer, and was patient enough to slog through the early kind of beta or alpha version of the guitar bot and compose a piece for it. That piece is the equivalent of digital sheet music. It's what we call a sequence, and it just is a roll of MIDI notes that goes streaming by, sending them to the guitar bot and playing them back. So that's entirely pre-composed. On the other end of the spectrum, the next person we worked with is an amazing violinist, composer, and laptop musician, programmer, Mari Kimura, that has been doing what we call interactive music. That is playing the violin and having the laptop analyze it and generate, in the past, before this, synthesized sounds and synthesized music. So I said, hey, Mari, would you like to do some music for a robot? And she was pregnant at the time and looking for things she could do sitting down. And so she's like, yeah, cool. And so brought the guitar bot to her, and she hooked her laptop up to it and started creating software. Instead of composing, in this piece she has the laptop listening to and analyzing the violin and making up the guitar bot part on the fly. So it's a set of rules, compositional rules that she's created, but the computer is doing the composing. And there isn't any pre-written music for the guitar. I'm going to go quickly through a lot of this stuff because, as I often do, I'm going to run over time if I don't. Anyway, so with this piece, she plays something and the guitar bot reacts in some way. She never knows exactly what it's going to do because, one, she's never playing the parts exactly the same way, and she's improvising in different parts. And two, there's a little bit of randomness coded into it. So, she'll play something and guitar bot will play it back. She'll go, oh yeah? Well, how about this? And play something else. And it's this duet between human and machine. And she said, for the first time, she really felt like she was doing this duet. Even though she'd done it with the laptop before, now she has this kind of physical entity. And you might notice that it also bounces around and jumps up and down. That was actually a fortuitous accident by virtue of the way the stand was designed, but has become the dominant personality of this robot. So every time someone sees it, they're like, hey, I love the way it dances around. Did you mean to do that? And I'm like, yeah. But it's also saddled me with the responsibility that every time I make a new one of these, it has to have a stand that bounces up and down. So even the Model 2 of the Guitar Bot has the same kind of stand. Oh, wait, that should say 6A, so it hops below there, right? Okay, so I'm doing all the performance stuff first. And so, started with a few different composers, and then, started branching out and saying, well, let's get these things into as many people's hands as possible. I like a lot of different music, so I looked for a lot of different composers, and frankly, I didn't really care what kind of music it was or what genre, as long as the music was interesting to me and the composer was interesting. And then by 2007, we had enough people kind of interested and lined up that we could have a big concert with half a dozen different composers and performers. And I'm just going to show some excerpts from this. The concert was called Robosonic Eclectic, Live Music by Robots and Humans. And everyone you see in here is a different composer / performer. They're all using different instrumentation, different technical setups, different software, all of this kind of stuff, which made teching the show a total nightmare, but the end result being really amazing. And so everyone approached this differently. The commonality is that there's a set of robotic instruments. So all you've seen so far is the Guitar Bot. I'm going to kind of fast forward a few years, and now there's this whole body of instruments, including mallet instruments like the Xylobot and a whole bunch of percussion instruments, which you'll see kind of arrayed around the room in here. And I'll just quickly play excerpts of the 4 different composers. This is Jim Thirlwell. He used to be kind of an industrial and punk artist, but he's reinvented himself as a new music composer. He does a lot of string quartets nowadays, and has done commissions for Kronos Quartet. So he's just playing back the Guitar Bot parts the robot parts from laptop, following along and conducting the poor string quartet that has to keep up with the robots. So this is really like human enslavement by robots. We knew it would happen. So string quartet and robots. This is Mort Subotnick, may know as one of the grandfathers of computer music. He's the guy on laptop. There's the Xylobot. There's some percussion instruments. There's Mort. So that's a duet for laptop, percussionist, and robots. Next guy is George Lewis, an amazing free jazz improvising trombone player, as well as an amazing computer musician. Again, he's got a program listening to the trombone and generating the robot parts. And then because these guys are one of my favorite bands in the world, I said, I was talking to them, I said, hey guys, would you like to make a piece for robots? And they made 3 of them. So They Might Be Giants. And this is kind of coming full circle for them, because they started out playing with synthesizer backing band, and then they got a real band, and now they're back again playing with the robotic band instead. So in case you were wondering if they can play real music, they can. They can rock. So, all right. So, there's a kind of brief performance history of the group. And since I keep saying the group, let me explain that. So I moved here last year from Brooklyn, where I'd been for 15 years. And I had this group for about 10 years at this point. And it was always designed as a collective, get a lot of different people's ideas in. And then eventually we started getting apprentices, interns to come in and learn what we were doing, learn how to machine, contribute software. We had artists in residence who were from every walk of life, every different kind of art. Probably not every different kind of art, but a lot. We had musicians and composers, but we also had dancers, visual artists, installation artists, theatrical artists, on and on. And the way we ran it was, we accepted proposals and we picked people whose work was interesting regardless of what background they came from, and then we gave them a couple of months to do whatever they wanted with the robots and the other technology. This is how we got a lot of performances, and through the intern program is how we got a lot of instruments with a lot of parts built, and you'll see those in the next part. And so in 2009, having done 15 years hard time in Brooklyn, I decided I was ready for a break from that and came back to Pittsburgh and discovered what a really awesome city it is. And now I tell all of my New York friends, when you're tired of paying $1,500 for a studio the size of that table and waiting tables so you can do your art on weekends, move to Pittsburgh. So we did a lot of performance work, and then we started doing installation work as well. And this, the first thing we did was installation at UC Irvine at the Beale Center for Art and Technology. There's video of that on the website. We want to jump to a video where we were commissioned to build instruments for a piece called Ballet Mécanique. Now, very briefly, you can look up Untitled.org and get the backstory on this. National Gallery of Art was doing a Dada exhibit, and they wanted to do this Dada's piece that was written in the 20s for 16 synchronized pianos and human percussion. Long story short, the piece was never performed because the technology to do that didn't exist. The composer died, and then many years after his death, his publishing company went to a guy named Paul Lehrman and said, hey, now the technology is here, can we do the piece? And so Paul revived the piece, got a percussion orchestra to play it, and it's had many performances, about 30 at this point, where they get 16-player pianos to play, and the humans play the percussion parts. But this is for an installation, and you can't really have musicians come to a museum twice a day for 3 months to play for 10 minutes because it would be ridiculously expensive and kind of boring for the musicians. But you can't have robots do that, and the piece being called Ballet Mécanique and the style in which it was composed really lends itself to this. So this is a piece where we created a whole body of percussion instruments to be used in the installation. Watch the audience when the piece starts. It's my favorite part. We didn't make the pianos, they were donated, but we made the xylophones. There's 3 of those. There's 4 bass drums, there's a gong, there's a bunch of doorbells you're hearing. There's an air raid siren, and this is all from the score, the original score. And the score also calls for 3 airplane propellers. No kidding. And they were always simulated by using electric fans. So coming up here for about a split second, you'll hear and then you'll see the way we solved that problem. There it is. So we got some industrial fans, and we put little pieces of plastic on a bar connected to a solenoid, dropped them into the blades, and all of this is MIDI controlled, so Paul could take the original score that he had encoded into the computer and just, boom, plug them in and play the stuff back. So this has been done a few times, and if you know anyone that's interested in this installation and has a large venue and $50,000, we would love to do it again. And then from there, developed our own installation. And this kind of evolved over many years and has now become what's called the Lemur Tron. And this video is actually from the Pittsburgh Children's Museum. And again, I'm going to play it and talk over it. So if you want to hear it without my voice, you'll have to. Actually, you can't hear it without my voice because I'm talking on the video. But the way this works is robots all around the room, and this is something that I always kind of liked, and it came from one of the other guys in the group, is doing real surround sound. That is like, sticking actual physical instruments all over the room, hanging them, mounting them from the floor, freestanding, and all of that. Doing a video projection in the middle of the room, and all of this, by the way, is controlled from a single Mac Mini. All of the video is being generated from Mac's, which is now, by the way, called Mac's MSP Jitter, which is the MIDI digital audio and digital video components, respectively, but it's all kind of merged together into one. So Mac's is generating the video that you see. It's doing the vision tracking, which is done in infrared, so the camera only sees IR bouncing off of the people walking through. It's not getting feedback from the video projection or anything. It's generating a user interface which is being changed by the motion of the participants, and then based on what they do and what happens with the video objects, it plays the robot's corresponding ways. So, the easiest example to understand is billiard balls. Every time the billiard balls collide, they set off a pair of corresponding robots.
In another scenario, the children's motion
and then very simple stuff, just mapping position to notes on the xylophone. And since we saw it before, back here, the spinner, you kick the game spinner around, and it moves the motors in a speed proportional to the speed of the spinner, so very intuitive. And what's not immediately obvious is the fact that this is an immersive, multi-user interactive environment utilizing interactive video, video tracking, so a non-invasive sensor system, sound and robotics, and it all works together. And kids love it, and more than one person can interact with it at a time and still know what they're doing. So that's kind of cool. I mean, that's kind of a hard thing to do, is to make something interactive and yet have more than one person know that they're affecting what's going on. If one kid is walking on the low part of the xylophone, the low notes are going off, and then the one who's walking on the high part hears the high parts going off. So that was, to me, this is a big accomplishment and kind of like the pinnacle of everything that I've been trying to do. In 2008, I got a call from Pat Metheny, jazz guitar player, who said, I want to tour the world with a whole band of robots. And I said, we can do that for you. And out of that project came what he calls the Orchestrion. And he spent 2009 recording an album with these called the Orchestrion album. And 2010, about half of the year touring through Europe, the US, and Asia, and then back to the US again. Every night, every morning, driving to a new city, setting up the robots on stage, sound checking at 5, playing a 3-hour concert at 8, breaking them all down, putting them back on the truck, driving to the next city, doing it all again. This is a lot of stress on machines. So they're all designed and entirely over-engineered, like, 30-amp transistors driving 3-amp solenoids. So this stuff is nearly bulletproof. All of the mechanical systems, the beaters, shakers, the guitar bot, all of this stuff has been re-engineered over and over again over the years by us to be as simple as possible. So it was like, first you get it to work, and then you just start taking parts off of it till you're down to the essence, and then you'll have something that'll work all the time. This is not a trivial lesson for those of us playing around with mechanical stuff. So this has been all over the world, and at the end of the tour I said, hey, Pat, how did everything work? And he said, your instruments were the least of our problem. And that was really gratifying to hear. So very quick excerpt of this variety of instruments. We built most of these. You'll see there's 3 mallet instruments here, about 10 cymbals, 10 drums, a whole bunch of shakers. There's a panorama of the instruments. There's a few things we didn't make. A couple of the guitars that were on the wall, these kind of weird bottle organs that would blow air over the top of differently filled bottles. So there are a few other creators involved in that. There's more video on his website of this stuff. And so, doing robots for a long time, but then thinking, I'm kind of sad because I miss making strange controllers. So we had all the stuff and all the tools and the technology to do it, so started going back and making a bunch of different controllers. This is called the Chimatron. Up to a... It's essentially, it's MIDI wind chimes. And the strange sound you hear, and kind of lo-fi in this case, is it's playing back a singing synthesis algorithm, which is a bunch of vowel sounds, and it's evolving the vowel sounds and the timbre of the singing, but every time a pair of those chimes touch each other, it makes a different one of these vocal algorithms sing and go ah, ah. So it sounds really strange, and I like that. Like I said, I kind of look around at the world and say, how can this be a musical instrument? And in this case, I was creating slime, the stuff you buy at Toys R Us, but you can make it home with my daughter. There's some slime. And of course, the thought jumped in my head, how can I turn slime into a musical instrument? So I added graphite to it to make it conductive, and built a little box here. And the brain behind this box, it's got a whole bunch of nails in it that can sense the conduction. Under this box is a thing called the Midi Tron, which I use in a lot of my instruments. And it's a little board that I happen to sell, shameless plug. I'll show you the website for that later. Later in like the 2 minutes I have left. And essentially it's something I created a long time ago to make it really easy for people who don't want to learn how to program a microprocessor and build all those support electronics for it. It's got MIDI in, MIDI out, 20 terminals that can be any combination of digital or analog input or output. All you do is use a menu program to configure it, and now you can do anything like take a bend sensor in and have it send MIDI controller number 7, which happens to be volume control, and now you've got a bending volume control. And it's really kind of that simple. So I have this sensing the slime, sending stuff to the computer, and again, generating controls in Max. Quiet, Eric. Just let the music play. The sound patch for this was created by another guy in the group. And I don't know how this happened, but the music kind of sounds slimy. Sort of sounds like rolling slime around in a box. Sometimes you get these sort of musical onomatopoeias going. And because I put this in the title of the talk, I'll go back out on that Madagascar Institute tangent and say, so one day, having people with a lot of different skills in the group, there were those of us who were into making electronic musical instruments, and then those of us who were figuring out how to build flame cannons, and we met in the middle and started creating MIDI-controlled flame cannons. And the result is an instrument like this. It's what you call a pyrophone. This is a percussive pyrophone. And by putting different fittings on the top of these, you get different kind of percussion sounds. You can run this from a keyboard if you want. You can run it from a synth. You can run it from a computer, as it is in this case. And in this case, it's being driven by a step sequencer, which some of you may know is you have time on one axis, and in this case, corresponding propane tank on the other axis. And any place that there's a dot or a connection, it scans across and it plays the corresponding tank. And that's called a step sequencer. In this case, it's literally a step sequencer because it's a bunch of boxes. It's a big 8x8 square with a bunch of LEDs on it and buttons. And wherever you step, it creates a dot in the sequence. So as it scans those locations, it plays the cannons. So there you go, musical instrument with propane. I will end with one thing because it's really fun, and it's one of my favorite things to have built. Any of you remember the video game or electronic game Simon, created in the late 70s, early 80s, where there's a bunch of lights and you follow the pattern and it adds one to the length of the pattern each time, and you go deet, 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 right? So this is kind of like Simon in hell. You're in the middle of it, and you simply have to follow the explosions and repeat the pattern on the buttons. If you are having a party and you want me to bring this, just email me seriously, because I love to run it and I don't often get a chance because of logistical reasons. Can't really just set it up in a carnival or anything like that. And brief side story, I heard that there was an anarchist ball event going on that the Bike Free people, I think, put on. So I emailed them and I said, hey, I have this thing, Flaming Simon. Would you like me to bring it to the ball? And the guy wrote back and he said, well, I don't know, is this legal? Do you have permits for it? And I emailed him back and I said, do you understand the irony here? I didn't hear back from him. I'll show one more thing. You can tell that this is not shot in the U.S. By this part. This would never happen in the U.S. Hey, 6-year-old, go in there and play. Of course, he was actually one of the best. So there's that. How do we up the what do you call it? The screen. Yeah, the intuitive. Okay. There we go. And how do I kill the projector? There we go. So that's my contact info. These are the URLs of my life. This is my incredibly outdated personal website that has half of that video. This is the Lemur site. This is where you find the Midi Tron. It's also where you find a link to a class, another shameless plug, that I'm teaching on November 13th. So if you want to learn how to build a flame cannon, take the class. It's pretty cheap, too. Madagascar Institute, they continue on to this day. They're really favorite sons now of Make magazine, so they're covered in there a lot. Flaming Simon for that video. The reason I'm teaching flamethrower classes is so all of you can learn how to make your own fire sculptures and be in Braddock's first annual Fire Arts Festival next October. Go to pyrotopia.net. There's very little up there right now, but it has the dates. And if you like the street event kind of thing, go to entropysyndicate.com, where I won't even talk about that now, but you guys can go discover it. And in conclusion, I was just speaking at Maya a few days ago, and the guy who invited me, I said, this is really cool, because the room had a curved whiteboard going all around the room, and he said, well, if you want to impress people, you should put a formula up on the board. And I couldn't really think of a formula, but I did remember something I'd done a few weeks ago on 10-10-10, when everyone was really excited about the calendar lining up like that. And so I did some calculations, and I found out that if you convert 10-10-10 into base 2.894, you come up with a very frightening and significant number. And I'll let you people with calculators figure that out, and whoever comes up with it first can write it up on the board. Please round to 0 significant digits past the decimal place. So I'll leave it at that. If you want to contact me, email there. I, as well as Lemur, have mailing lists and Facebook presences and Twitter feeds, and I am starting to do more stuff around Pittsburgh. And if you're interested in getting involved and helping out with the stuff that I'm doing, I'm not quite taking interns yet, but I want to know who's out there. And like today, I'm doing an installation for a Halloween party that's going on tomorrow, and can use help with that. Not saying you guys have to come and help me, but I often have interesting things going on that I need more people for. So it's a way to learn about installations, learn how to make things out of fire without burning yourself, kind of just get involved in the interesting stuff that you've seen up here. That's all. Any questions? Thank you. Right there.
So I apologize if you covered this when I walked in a couple minutes late, but I come from a contemporary art and installation art background, and it's really interesting for me to see the link between the work you do and other artists, and also people who bridge the gap between music and art, like John Cage. And I was wondering if you could talk about what you feel like some of your main creative influences have been.
I'm sorry, we already talked about that. A few weeks ago, I sort of declared in my mind that I was now medium agnostic, meaning that I no longer care about what materials or media that I use in my work. All I really care about is the idea, and that I better get a day job that would pay me so I don't have to decide whether the thing that I want to make is going to make me money. So if any of you have a good job that needs to be filled, let me know. Meanwhile, I'm just starting to do projects that I don't know how to do, and find the people that are interested in collaborating. So, one of my influences is simply the idea that the medium is not the message. The message is the idea, and you combine whatever you think is interesting to do, to create what you want to create. And this is kind of touches on the whole maker movement and hackerspace movement that's going on now. And if I have anything to do with it, which I hope to, Pittsburgh by next year will have a fairly large space where you can go to learn and do art, technology, and machining, fabrication in one giant space, because Pittsburgh needs one of these. Not everyone goes to school here, and even the ones that do don't have access to all of the labs at the Robotics Institute to create stuff. So I think it's a real kind of niche to be filled. And the people that will come there, I hope, are people from all walks of life with all variety of skills, and talk to each other and come up with ideas and make things. As far as what people are influences have influenced my work, probably the first two major influences would have been Frank Zappa and his music and the what he would call the statistical density of his music, and Conlon Nancarrow, who I first found out about because Zappa mentions him in one of his songs. Nancaro was the first guy to really do serious music sequencing, but this is way before there were electronics to do it on. He wrote music that was not playable by humans, but only by player pianos, and he would cut his own player piano rolls and could do all of these experiments by, taking 7 against 11 time that like people could never compute and play, and doing things that sounded like insane people playing the blues as fast as possible with 8 hands. So, if you write for a player piano, it can do that. So definitely Nancaro's work. My early professors like Roger Dannenberg and Richard Boulanger, Robert Rowe, Ken Perlin at NYU, all of them had a hand in shaping where I went. Sorry, I hear voices. Halloween is near. Other artists, a few of my contemporaries and people that I've worked with, a guy named Luc Dubois, who did all of the video work that you saw for the installation, is a musician, video artist, programmer, all-around great guy, one of the programmers on the Jitter project. So, check him out. A lot of comedians like Bill Hicks and Andy Kaufman, because I like the way cutting-edge comedians think, and so I don't know, I like my work to be amusing. I like to do strange, funny things on the street corner. So, all over the place. It doesn't matter to me what kind of, I'm not like really into, the blues or really into modern dance or anything like that. I'm really into anyone kind of creating cool and interesting work, and I don't even necessarily have to love the work if I love what the person's trying to get across or what they're putting into their work. I think art is hard, and good art is really hard, and I appreciate when I see the work in the art, when I see that people have sweat over their work. Like they say, 10% inspiration and 90% perspiration. If you're lucky, every so often you come up with that 90% inspiration idea and you only have 10% of work left to do. But that's the long answer. Email me if you want an even longer one. Other questions? Yes?
Who pays for all that? How much?
No one. I just have driven myself into bankruptcy. Pretty close, living in New York. But who pays for it? I've gotten a lot of grants. Grants from a lot of different organizations in New York, and a lot of support for the work that way. After a while, I started thinking like, okay, so you spent a lot of time writing a grant, and if this was a real business proposal, it would sort of sound like, here's my proposal, and then the company going, looks great, don't talk to us for 9 months, and then we'll come back to you and tell you if we're going to give you the contract, and we'll tell you how much we're going to pay you. And it wouldn't fly in any other business, and it shouldn't be the way in art. So I started trying to get away from the grant thing and more into getting shows, getting concerts, and getting museum installations, and now I'm really focusing on the museum installation angle on things, because that is the kind of thing where you can put a show somewhere for 3 or 6 months and make a good amount of money on that. And once it's up and running, because these things are designed to just do their own work, then I don't have to do anything, and the money just comes rolling in like that. It's tough, people don't like to pay for art. They think it's free, and it often is, and artists often end up working for nothing just for exposure, and I still do that, but it has to be really fun exposure, like doing an installation for a Halloween party, but also kind of any way I can that's interesting to me. So selling these boards through the net brought in money. I did some early video sensing software, motion sensing software for Macs, and I did actually put a lot of Macs plugins out there for free, but the one that I spent like a year working on, I decided sell that one. And so I got some income through that. Eventually, Cycling 74, the company that owns Max, bought me out on that, and that was a good thing because now they handle it, and I got some money for that. So it's sort of like if you want to do what you want to do, you figure out how to make money any way you can. So now I'm back thinking about doing adjunct teaching, which I've done in the past, and consulting work, whatever. Anything that just puts me in a position where I can, wake up one morning and go, I want to make a, MIDI hot dog machine and just do it, even though I know that no one will ever buy it, even on eBay. So that's kind of how I'm thinking about things now.
Where's this Halloween party? Can we crash it?
You probably won't be able to crash it, but you can get advance tickets now for $30. They're $40 at the door. It's Eveline, which you can. No, it takes place at someone's house. It's been going on for about 20 years now, and someone just named it one of the top 10 Halloween parties in the U.S. Something like that. But it's filled with installations and drunk people and costumes and everything that we all like. I have the Xylobot that's going to be playing Halloween music there, but good Halloween music, not like just the Addams Family, Peer Gynt and Danse Macabre and all that kind of stuff. And if I manage to get this working, which is why I'm going to have to fly out of here in a minute, by tomorrow, a kind of warped version of a photo booth. And you'll hopefully see that at other events in the future. So yeah, come to the party if you want to come to a cool party.
And just to make it clear, especially for the people who maybe see this later, this is Halloween night or tomorrow night?
Yeah, so right, it's Saturday night, tomorrow. Not Halloween. So you can still go trick-or-treating if you wake up in time. So yeah, Eveline, just go on, I don't know, Google it or email me and I'll send you a link. But if you turn from Friendship up the corner that Silky's Bar is and go right past the church, then like the second house on the left is where you buy your tickets. And where the party is. Was there another question in the back? Or both of you guys.
This might not be a real question.
If you ask it, it's a real question.
What do you think of letting your robots help people with moral, physical disability or limited dexterity be able to play musical instruments?
Yeah, it's definitely possible. I love the idea of it. I, a while back, collaborated with some people and started looking into leveraging sensors and technology for disabled people and that whole world, but it kind of couldn't figure out how to navigate that world because there's a lot of people in it already and a lot of people more experienced than I am. But I'm always open to these kinds of ideas, and sometimes they happen. People come to me and say, I want to, I have a grant to make, allow people who are disabled to play musical instruments, and I say, cool, that sounds interesting to me. I'm happy to be involved. So that's how the most interesting projects happen, is just, and if you have the idea and you want to collaborate with me or someone else, then go for it. There's a lot of work that can be done in that area. It's kind of in its infancy. The sensor technology is really cheap now and really available. You can build something that can help a disabled person for about $20, and well, $20 in a laptop. But laptops are cheap now, and Mac Minis and things like that. And you don't have to use a laptop, right? You can do a lot of stuff on a microprocessor that used to take an entire room full of Apple IIs. So that's my thought on that. Gentleman next to you had a question? No?
Maybe, I think it's my job to kind of stop things.
Probably.
I want to really stop the questions. Anybody?
If you guys want to come up and talk.
I don't know. You can fly out eventually, I guess.
Yeah, I'll hang out for a few minutes for questions.
But thank you very much. It's been fantastic.
Okay. And since no one...
666.
That's right.